Arithmetic square roots. Chapter 2. Understand the basic concept of arithmetic square roots and being able to perform basic calculations with them. So last time we learned all about irrational numbers and some examples of them and their properties. This time we're going to be learning about square roots. This might sound a bit strange to you, but this is something completely new, so don't worry if you don't understand it right away. So this is part 1. Understands the concept and properties of arithmetic square roots. Can find the arithmetic square root of a number. So here's an introduction. The school is about to hold an art competition. Ethan is very excited. He wants to cut out a square canvas with an area of 25 dm squared and paint his proud work to participate in the competition. What is the side length of his square canvas? Can you help Ethan do the calculations? You can pause the video to ponder about this for a moment, and then we're going to be finding out the answer. Okay. Well, 5 dm, because 5 squared equals 25. We know that it's a square canvas, because so 5 times 5 equals 25. So 5 dm is the answer. The concept of arithmetic square roots. Fill in the blanks 1. Knowing the area of a figure, of a square, find the side length of it. And something I need to tell you is that a square has all equal sides. Okay. The answers are 1, 3, 4, 6, and 0.5. Did you get that one right? I would like to cover the last one because it's decimals. Something that you should keep in mind is that it's a decimal. For me, sometimes when it's like more simpler numbers, for example 0.25, I know, well, this has 2 place values behind the decimal point, so that means that my answer has to only have 1 place value behind the decimal point. And I just do 25, 25, and what times what equals 25? 5 does. So just going to be 1 5 behind the decimal point. But I think the more efficient way to solve this, if you're a beginner in this, is to take 0.25 and convert it into a fraction. So take this and convert it into a fraction, which would be 1/4, and the side length of it. So what times what equals 1/4? 1/2 does. So your answer can be in a fraction form, or if you want to, 0.5 decimal form. Fill in the blanks too. Please fill in the blanks according to the Pythagorean Theorem and this picture. So what is x squared, y squared, z squared, and w squared? So this shouldn't be too hard because we've just learned the Pythagorean Theorem. Alright, first one, it's 2. So x is equal to 1 squared plus 1 squared, which is equal to 2. Y is equal to 3 because this is the hypotenuse of the right triangle, and x and 1 are both legs. So since we know x is 2, so then 2 squared plus 1 squared equals 3. Which of these are rational numbers? What are irrational numbers? How can you express them? So let's learn the concept. Usually, if the square of a positive x equals a, and x squared equals a, then x is the arithmetic square root of a. It is written as this, and in red as arithmetic square root of a. Usually we define the arithmetic square root of 0 is 0. So the arithmetic square root of 0 is equal to 0. these points right here of what is an arithmetic square root, that how x has to be positive, or not, or 0, x has to be positive or 0. And these are all points you need to be writing down in your notebook because this is something very, very important, one of the main points we're going to be looking at in this lesson. Try. Can you tell the arithmetic square root of 144 based on the equation 12 squared equals 144? Express it with an equation. Think, what does the following formulas mean? Can you find their value? Well, we already have this. So 49, 49, so the arithmetic square root of 49 is equal to 7. The arithmetic square root of 13 squared is equal to 13. And the arithmetic square root of 0.0009 is equal to 0.03. Not too hard. Okay. Example 1. Find the arithmetic square roots of the following numbers: 900, 1, 49 over 64, and 14. So over here, there's already the first one. The arithmetic square root of 900 is equal to 30. Because 1 squared is equal to 1, so the arithmetic square root of 1 is 1, and this. So the arithmetic square root of 1 is equal to 1. Okay. 3. Because 7/8 squared is equal to 49 over 64, so the arithmetic square root of 49 over 64 is equal to 7 over 8, and 49, the arithmetic square root of 49 over 64 is equal to 7 over 8. And if you look at this, the top 49 is just the square of 7, 64 on the bottom, on the denominator side. 64 is 8 times 8. 4. The arithmetic square root of 14 is just the arithmetic root of 14. So the arithmetic square root of a non-square number can only be represented by the squares, by the root sign. So to be the simplest form, if, for example, 14, it's not a perfect square, so all you do is just add that sign and you have the arithmetic square root of 14. Practice. Find the arithmetic square root of the following numbers. So there's 81. So there's the arithmetic square root of 81, negative 25 squared, and 2 and 1/4. First one, well, because 81's arithmetic square root is equal to 9, so the arithmetic square root of 81 is 3. So what this is saying over here is actually this. So we're first going to start with the middle, all right, with the very inside. So 81 arithmetic square root is 9. And then we still have this extra layer over here, and that makes it 3. So the answer for the first problem is 3, in case you got confused. Okay, so the answer to the second problem is 25. Notice does not equal negative 25 because it already talks about how on the middle, how on the inside it has to be, so right here. In here, x has to be greater or equal to 0. So x cannot be a negative number, so it does not equal negative 25. And for 2 and 1/4, what you do is you just first convert it into an improper fraction, 9/4, which equals 3 halves. And in this case, it's not a decimal, it's a mixed number, so it's going to be harder. So in this case, I totally recommend you to turn it into an improper fraction first. So the mixed number is turned into an improper fraction first for easy calculation. Now applying the concept. Question 1. Do negative numbers have arithmetic square roots? Question 2. Can the arithmetic square root of a non-negative number be negative? Okay. So this is the arithmetic square root. This is the concept. So we need to know that this whole thing right here is non-negative. So the answer, the arithmetic square root, has to be greater or equal to 0. It cannot, this answer right here cannot be negative, and a itself cannot be negative either. So the arithmetic square root concept has double non-negativity rule, which is something you need to write down in case you haven't yet. And it says that the arithmetic square root of any number has to be greater or equal to 0, and the number inside the square root itself has to be greater and equal to 0 as well. Remember, it's not greater than 0, it's greater or equal to 0. So this means that it includes 0 itself. Yes, 0 is a very special number. Okay, now here's a if the absolute value of n minus 1 plus the square root of n plus 3 is equal to 0, find m plus n. Okay, so let's do this together. Because absolute values have to be greater or equal to than 0, and square roots, arithmetic square roots also have to be greater or equal to than 0, then n minus 1 absolute value plus the square root of n plus 3 is equal to 0. So then n minus 1 itself has to equal 0, and the square root of 0 plus 3 has to equal 0 as well. Because both of these, this is absolute value, and this is square roots. So they both have to be greater or equal to 0. But if added together they equal 0, then they have to equal 0 themselves. So that's the logic here. So after the rules and applying the concept, we get that m is equal to 1 and n is equal to negative 3. Then what we do is just add them because we're trying to find m plus n. So 1 plus negative 3 is equal to negative 2. So here's a conclusion. The sum of several non-negative numbers is 0, then each number is 0. The non-negative numbers learned in middle school have absolute value, even the power and arithmetic square root of a number too. So some more practice of this type of problem. So why don't you pause the video, and then after you're done, come back and we'll check the answers. Okay, so the first one is pretty simple. It just a plus 3's absolute value is equal to 0. So then a has to equal negative 3. Second problem. If the square of m minus 7 is equal to 0, then m equals what? Well, squares have to be greater or equal to than 0. So then in this case, it is equal to 0. That means that on the inside, m has to equal 7. 3. If the square root of a minus 5 is equal to 0, then a equals what? Well, square roots, the same as the two problems above it, have to be greater or equal to than 0. And in this case, it is equal to 0, so which means that a has to equal 5. Example 3. The relationship between the following distance h meters of a free-falling object and the following time t is h equals 4.9 t squared. How long does it take for an iron ball to fall freely from a 19.6 meter high building? Alright, so we can substitute h equals 19.6 into this expression given, and we'll get that t squared is equal to 4. So t is equal to the square root of 4, which is equal to 2, so 2 seconds. The iron ball would take 2 seconds to fall to the ground. Class summary. We learned all about arithmetic square roots, and in it there was the concept of the arithmetic square root, and the properties was the double non-negativity of the arithmetic square root and the application of arithmetic square roots. So if you have all of this down, if you don't, you should get it down because it's something very, very important, and it relates really largely to our next lesson as well. And if you're done, this is a lesson summary for today. We learned about the concept and properties of arithmetic square roots, and we could find the arithmetic square root of a number. So thank you for watching, and I'll see you in our next lesson about square